Hello everyone, welcome to Easy Ganit. This is Samir Sardana and I will be discussing the questions of probability from XAT 2008 to XAT 2021. These are the actual probability questions that I'll be discussing in this video and very important chapter for XAT 2022. Okay, so there are total around 13 questions from XAT 2008 to XAT 2021 of probability. You can see that every year you will definitely be getting at least one or two questions of probability. So these are the actual XAT paper questions that I'll be discussing with you. In the description part of the video, I have given the link of 3 special classes. These are the completely free special classes that I have taken on Unacademy for probability. There I have covered 100% theory of probability. You can watch these classes. These are completely free. However, in this video also, I'll be taking you through the basics, right? The small basics, right? Important basics that you're supposed to know if you want to solve all the question of XAT 2008 to XAT 2021. So these are the basics that we will first be discussing. There are only 5 or 6 slides that I'll be taking you through so that you can understand all previous year XAT paper questions of probability. And then these are the questions which are actual XAT paper questions of probability that we will be discussing in this video. So this is what I will be covering in the whole video, right? So there are total 12 questions, right, of the previous year's XAT paper that we will be discussing. Now, starting with the basic of probability first, student who have not studied the basics yet must know these definitions, must know this basic theory part to solve all these questions. If you want to study the complete concept of probability, please watch the previous 3 sessions. If you want more practice question, watch the 3 special classes that I have given to you in the description part of this video. Now guys, the complete chapter of probability is based on this one basic concept that any probability of any event occurring is basically the number of favorable outcomes divided by total number of possible outcomes. Now what is outcome? What are the total number of outcome? What is a favorable outcome? What is an event? It's very basic. I'll give you an example and you will be able to understand it. See guys, probability, all questions of probability are basically comes from the random experiment. Now, what is an experiment? Experiment can be of 2 types. See guys, whenever we do an experiment, it can be of 2 types. One is deterministic experiment, right? Deterministic experiment, right? And the second one is random experiment. Now, what is a deterministic experiment? Deterministic experiment are those experiments where we already know the result. What is going to be the outcome? We already know that, right? Outcome is already known. Those are the deterministic experiment. But in the random experiment, we do not know the exact outcome. We only know the possible outcomes. So in random experiment, only possible outcomes are known. That experiment is called as random experiment. And all questions of probability comes from the random experiment. For example, when I throw a dice, I know that my possible outcomes will be 1, 2, 3, 4, 5, 6. And this possible outcomes will be called as my total sample space. All set of, right, the set of all possible outcome is called as total sample space, right? So guys, when I'm doing a random experiment like throwing a dice, these are my possible outcomes 1, 2, 3, 4, 5, 6, right? Event is something which is a subset of the sample space. For example, as you can see that here I have written probability of an event occurring is number of favorable outcomes divided by total number of possible outcomes, right? So when it comes to the event is a subset of a random experiment. For example, out of these possible outcomes, if I define my event as a number which is a multiple of 3. So a multiple of 3 out of these possible outcomes are only 2, that is 3 and 6. So you can see that an event is a subset of my total sample space, right? So 3 and 6 are just 2 possible outcomes out of my total possible outcomes, right? So if I want to find out the probability of getting a number which is a multiple of 3 on throwing a dice, you see that my number of favorable outcomes will be 3 and 6, that is 2. And my total number of possible outcomes, that means number of my sample space is 6. 2 by 6, answer will be 1 by 3. This is the basic of probability that you're supposed to know, right? The whole chapter of probability is based on this, right? So you should know that what is an event, you should know what is a random experiment, what is sample space, what is a favorable outcome, what are the possible outcomes, right? So guys, this is where the chapter of probability starts. Next is independent events. I'm quickly taking you through all these terms because these are very important to do all the questions of previous year paper of XAT. If you need more practice, you want to understand these concepts at depth, please watch the 3 special class sessions in the description part of the video. Now, what is independent event? Two events are said to be independent when the outcome of one of the event does not affect the outcome of the other event. What is the meaning of it? Very simple to understand. Let's understand an example. If I'm flipping a coin, I know that on flipping a coin, I'll be getting the outcome as head or tail. So these are the two possible outcomes on flipping a coin. Now, happening of head on flipping a coin prevent the happening of tail, right? So if I'm getting head, tail cannot happen. If I'm getting tail, head cannot happen, right? So happening of one event is not at all affected by the happening of other event. So head probability is 1 by 2, right? Favorable cases of head is 1, total number of cases are 2, tail is also 1 by 2. But getting a head on flipping a coin and getting a tail on flipping a coin are completely independent of each other, right? So probability of happening of event A and B, if both event A and B are independent, will be straight away be written as PA into PB. Right. For example, if I'm flipping a coin for 2 times, I want head on the first coin and tail on the second coin. Probability of getting a head on the first coin is 1 by 2. Probability of getting a tail on the second coin is also 1 by 2. So total probability of getting a head on first and tail on second would be 1 by 4. That is P, A and B. There's one more example I have written over here. A coin is thrown 5 times. What's the probability of getting HT, HTT? That means on the first coin, I need head. Probability is 1 by 2. On second coin, I need tail. The probability is 1 by 2. Again, head on third coin is again 1 by 2. Tail on the fourth coin is again 1 by 2. Tail on the fifth coin is again 1 by 2. So my probability of getting this particular event will be 1 upon 2 power 5. That is 1 upon 32, everybody. Is it clear? That means probability of getting head and tail and head then and tail is actually probability of getting head multiplied by probability of getting tail and so on. That is, in the case of independent events, probability of happening of event A and B will be PA into PB straight away. Now, the next that you're supposed to know is probability of union. That means event A or event B. So if I want to find out the probability of happening of event A or B, that will be equal to PA plus PB minus PA intersection B. You can understand it with the concept of set theory. For example, if I say that this is my probability of happening of event A, and this is the happening of probability of event B, right? This is probability of happening of event A, this is probability of happening of event B, and this you can see is probability of happening of event A intersection B, right? Now if I want to find out the probability of happening of event A or event B, that will be PA plus PB minus PA intersection B. Example is, let's say the probability of A solving the problem is 2 by 3. So probability of A solving the problem, that means this circle is given to me as 2 by 3. This is given to me as 2 by 3. Probability of B solving the problem is 1 by 2. Probability, what is the probability that the problem is solved, right? So guys, what I need is problem will be solved. That means either A solve the problem or B solve the problem, right? Either A solve the problem or B solve the problem, right? So, right, I can solve the question by solving, right, by putting the values in the equation here, right? Okay, so guys, PA, probability of A solving the problem is 2 by 3. Probability of B solving the problem is 1 by 2. Now think again, guys. Does the probability of B solving the problem in any way is dependent of probability A solving the problem? No. Probability that A is solving the problem and probability of B solving the problem is completely independent of each other. So can I say that PA and B will be nothing but PA multiplied by PB? That is 2 by 3 multiplied by 1 by 2. This get cancelled. You'll get your answer here. 2 by 3 plus 1 by 2, right? Minus 1 by 3 is 1 by 3 plus 1 upon 2, which is equal to 5 by 6. So the probability that the problem will get solved will be 5 by 6. Then the next thing that you're supposed to know is what is the complement of an event. This is very important concept and used in many questions and very helpful in reducing the calculation in probability question. What is the meaning of complement of event? Complement of event means if I say that event A is a favorable event, then the complement of A is defined as not as event A, that is not occurring. So basically, if A is PA is the probability of happening of event A, then the complement of A is probability of not happening the event A. And always keep this in mind, probability of happening of event A and probability of not happening of the event A will always be equal to 1. And this is something which is very important, and this makes our calculation very short. For example, here in this question, the question says a coin is tossed 6 times. What's the probability that at least one toss result in a head? I want at least one toss to result in a head. So if I subtract, I know that probability of happening of at least one head and the probability of not happening of head is definitely equal to 1. So if I want the probability of having at least one head will be equal to 1 minus the complete probability when I don't have any head. So when a coin is tossed 6 times and no output should be head, that means I want tail on all 6 tosses, right? So this is the outcome I want. How many favorable cases I have in the favor of this? This we know is 1 upon 2 raised to power 6. That is 1 minus 1 upon 64. So the answer would be 63 by 64. Why this is 1 upon 2 power 6? This is probability of having tail. All these events are independent. So 1 by 2, 1 by 2, 1 by 2, 1 by 2 into 1 by 2 into 1 by 2 is 1 upon 2 power 6. That is 63 by 64. That's the correct answer to the question, everybody. You can also see that I could have solved this question like here also. The complementary concept can also be solved in this question. I know that probability of solving the problem and probability of not solving the problem will always be equal to 1. So problem should get solved is 1 minus problem is not getting solved. Now the problem will not get solved when A is not solving the problem. A solve the problem is 2 by 3. A not solving the problem is 1 by 3. Problem that B solving the problem is 1 by 2. Not solving the problem will be 1 by 2. So 1 minus 1 upon 6. You see that? This also gives me the answer as 5 by 6. Sorry, I have written it here. I'll write it down. Problem solving the problem plus not solving the problem is 1. Problem solving the problem is 1 minus that problem is not getting solved. 1 minus A is not solving the problem. A solving the problem is 2 by 3. Not solving is 1 by 3. B solving the problem is 1 by 2. Not solving is 1 by 2. 1 minus 1 upon 6. Answer will be 5 by 6. Everybody? Okay. Now next which is very important is geometrical probability. Whenever you're solving a geometric probability, it is favorite of CAT. It is favorite of XAT. Geometric probability is favorable area upon total area. Right? In the case of events, we put down favorable events in the numerator and total number of events in the denominator. But when it comes to geometric based probability, you always put favorable area in the numerator and total area in the denominator. For example, in this question, it says a square is inscribed in a circle. If a point is selected inside the circle, then what is the probability that the point lies inside the square? So guys, we have a circle, right? We do not know what is the radius of this. And there is a square inside the circle that you have made. Any random point that you are picking from the circle should lie inside the square. What is that probability? Now we know that in square, all of these angles are at 90 degree, right? Let's say the square is A, B, C, D. All of these angles are 90 degree. Now, if all these angles are 90 degree, can I say that if this angle is 90, we know that only a diameter can make an angle of 90 degree at circumference of at any point on the circumference of the circle. So this must be the diameter and this must be the radius of the circle. Now, as I know that geometric probability is favorable area upon total area. Now guys, if I say that this side, because this is a square, if I say that this side is 1, this side is, let's say this is radius r, this is radius r, right? Then what will be my total favorable area? You see that the area of the complete circle would be pi r square, right? What is my favorable area? Favorable area is that I want point inside the circle. I want point to be inside the square, sorry. So I need, my favorable area is the area of the square. And to find out the area of square, what you need is the side, right? Now this is r, this is r. Now can I say that this is a, let's say this is a. Then 2a square will be equal to 4r square. That means a square will be equal to 2r square. The Pythagoras theorem. Can I say that? A will be equal to root 2r. If a is root 2r, area of square would be side square. That is root 2r square, right? Root 2r whole square. That is 2r square upon pi r square. So the probability that any selected point from the circle lies inside the square will be 2 upon pi, and that is the correct answer to the question, 2 upon pi. That's a geometric probability basic example. You want more practice? Please watch the special classes. Total probability. Now this is something which is very important. 90% questions of XAT comes through this total probability. And okay, so this actually okay, total probability and conditional probability are something which are actually connected with each other. I'll try to explain the concept of total probability with the help of this example. Look at it. It says that box 1 contains 3 red and 7 blue ball, right? We have 2 boxes, right? Now there's a box 1, right? In the box 1 we have 3 red, 7 blue ball. Then we have a box 2. In the box 2 we have 6 red and 4 blue balls, right? Now question says a dice is rolled if the outcome is a multiple of 3, a ball is drawn from box 1. Otherwise ball is drawn from box 2. What is the probability that the ball drawn is red? So guys, in this question you see that we are supposed to find out the probability of drawing a red ball. Now you know that probability of drawing a red ball from box 1 is different and the probability of drawing a red ball from box 2 is different. You see that if I'm picking the red ball from the box 1, the probability of taking the red ball from the box 1 you can see is 3 upon 10. And the probability of taking a red ball from box 2 you can see is 6 upon 10. Now if I want to find out the probability of drawing a red ball, then I need to know first which box I'm picking. I'm picking the red ball from which box. Now I can pick box 1 or can pick box 2. So you see that the probability of drawing a red ball is actually based on the box which I am picking. And the box that I'm picking is actually dependent on the outcome of the dice. So if I want to find out the red ball, the probability of finding a red ball, I need to find out the probability of selecting the box 1 and probability of selecting the red ball then. So you need to first select the box, right, out of box 1 and box 2. Now let's say that I'm selecting. So one of the event is that I'm first selecting the box 1 and then picking the red ball. Selecting the box 1 and then picking the red ball, that's the intersection between box 1 and red. Or I'm selecting the box 2 and then selecting the red ball. Now in this case, I first need to see that I'm first selecting the box 1 and then I'm selecting the red ball. Then I find the selecting the red ball provided it's given that box 1 has already been selected. I'm selecting box 2 and then I'm selecting I'm finding the probability of red ball provided that box 2 has already been selected. Now guys, tell me what is the probability of selecting the box 1. The probability of selecting box 1 is dependent on the output of the dice. Now in a dice I have 6 possible outcomes, 1 2 3 4 5 6. The number which is a multiple of 3, the favorable cases to get a number which is a multiple of 3 will tell me whether I'm selecting the box 1 or box 2. So the guys, probability of selecting the box 1 is same as the probability of getting a number which is a multiple of 3. The favorable cases is 2, total number of cases is 6, 1 upon 3. Probability, right? So probability of selecting the box 1 is 1 upon 3. Now probability of selecting the red ball from box 1 you can see is 3 by 10. Plus probability of selecting box 2 is getting any of these 4 outcomes other than multiple of 3, total number of cases, that is 2 by 3. So probability of selecting the box 2 and then selecting the red ball from box 2, that is 6 by 10. This is what you need to solve. This is what you need to solve, right? That is 1 upon 10 plus 2 upon 5. 1 upon 10 plus 2 upon 5. What 1 upon 10 plus 2 upon 5 guys? Let me solve it here. 1 upon 10 plus 2 upon 5 will be 10, 1, 5, 2. That's 5 by 10. That is 1 by 2, guys. That's the correct answer to the question, right? This is how you are supposed to solve this. 1 upon 2 will be the correct answer. So this is the total probability. What we are finding here? We are finding the total probability of drawing the red ball, right? Now, when it comes to the condition probability questions are solved through Bayes theorem. But again, you don't need that if you just try to understand the question. when it comes to the conditional probability, you can solve the question of conditional probability if you know how to find out the total probability. Because the only difference in the conditional probability is that in conditional probability, right, is a situation where the part of the information or where the part information of the outcome changes, where the part information is already given about the outcome, right? So conditional probability is that situation where the additional information is given to you. And the extra information of the outcome changes the probability of an event. For example, here in this question, look at it. This is exactly similar to the question that we were discussing in the previous slide. You see that box 1. We have a box 1, right? In this box 1, right, we have 3 red and 7 blue ball. We have 3 red and 7 blue ball. Then we have a box 2. And the box 2, we have 6 red and 4 blue balls, right? The question says a dice is rolled if the outcome is a multiple of 3, a ball is drawn from box 1, otherwise a ball is drawn from box 2, which is exactly similar to the previous question, right? But then there we were finding the probability of drawing a red ball, and in this question it says that the final ball that I'm drawing is actually red in color. So that you can see is an additional information. It is given to me that final output of the ball is red. So when I'm selecting the ball from the box 1, I'm not supposed to find out the probability of taking a red ball. It's given to me that the ball that I'm taking from the box 1 is red, as well as the ball I'm taking from box 2 is also red in color. And I'm supposed to find out what is the probability that it has been drawn from box 1. So guys, in this case, what I basically want to find out is a probability of drawing a red ball from box 1. A probability of drawing a red ball from box 1. So basically I'm supposed to find out probability of selecting the box 1, provided it's given that the ball drawn is red in color. Yes. Now this, you see that is actually, this will be equal to probability of drawing a red ball and provided probability of selecting the box 1, right, multiplied by probability of drawing a red ball provided that box 1 has already been selected, right? See guys, this is what we are supposed to find out. And probability of selecting the box 1 multiplied by probability of selecting the red ball provided that red ball probability of selecting the red ball provided that box 1 has already been selected, divided by probability of selecting the red ball. So in conditional probability, you will always put the total probability in the denominator. Now, what is the total probability in the denominator? It's P, probability of selecting the box 1 multiplied by exactly similar what we have discussed in the previous question, or probability of selecting the box 2 multiplied by probability of taking a red ball provided that the box 2 has already been selected. Now, out of these two events, we are supposed to put one event in the numerator. We see that. We want the probability that the red ball that we have drawn is coming from box 1. That means this event is supposed to be put as it is in the numerator. So if you know how to find out the total probability, all you need is to put one of the event in the numerator as per the given question's condition. Because we want to find out the probability that the red ball drawn is from box 1. So put the probability of drawing the red ball from box 1 in the numerator and the total probability in the denominator. As we have found in the previous question, our total probability is 1 by 2. That means this value we already know is 1 by 2. So put this in the numerator here in this question. And probability of selecting the box 1 and then selecting the red ball from box 1 is this part only, which is 1 upon 10. Put that value in the numerator. You get your answer as 1 upon 5. These are the questions, these are the basics that you're supposed to know. That's the complete theory of probability. But I have given you only one example. You need more practice? Watch special classes, right? 3 classes with 50 around questions on probability have been covered in these classes. You can refer to these. Okay? And also please use the code, right, that I have given to you in the description part of the video, sme.yt, to watch all these 3 special classes. Now let's start solving all these questions, right? These are the questions of XAT paper that I'm going to solve for you. Question number 1. Steel Express stop at 6 stations between Havra and Jamshedpur. 5 passengers board at Havra. Each passenger can get down at any station till Jamshedpur, right? The probability that all the 5 passengers will get down at different stations. See guys, this is very simple because here all I have to do is to find out the probability that all passengers get down at different station. I just need favorable cases in the numerator and the total cases in the denominator, right? This is all I want. So what is my favorable case, guys? Right, total number of cases, you see that every passenger has 7 options to get down. So first passenger have 7 options to get down, second passenger have 7 options to get down, third passenger also have 7 different stations to get down, right? So there are total 5 passengers, right? 5, 1, 2, 3, 4. So all of these 5 passengers have 7 choices to get down. That will be my total case. The probability that all person will get down at different station. That means if for the first person have seven choices to get down at any of the station, right? So let's say these are the 7 stations. 1, 2, 3, 4, 5, 6, 7. Let's say that first passenger gets down at this particular station, right? Now this station has now been used by a particular passenger. Now the second passenger who is trying to get down will not be able to get down at this station, but he can choose any of the rest of the 6. So second passenger will have 6 options to select any of the station, right? Let's say that second passenger has selected this station, right, to get down. Now this has also been used. Now for third passenger we have only 5 options. For fourth passenger, let's say that fourth passenger will have only 4 options, right? And the fifth passenger will have only 3 options, right? So this is my favorable case and this is my total case, right? 7 into 6 into 5 into 4 into 3. I haven't given you the options here in this question, but this actually was written like 7 into 6 into 5 into 4 into 3 is nothing but 7p5 divided by 7 power 5. This is the correct answer of the question. This is how the options were given in the question, right? 7c5 upon 7 power 5, 7p5 upon 7 power 5 and so on. So this option is the correct answer of the question. This is actual XAT paper question for you. Look at the next question, guys. Question number 2. The scheduling officer for a local police department is trying to schedule additional patrol unit in each of the 2 neighborhoods, southern and northern region. He knows that on any given day, the probability of major crimes and minor crimes being committed in the northern neighborhood respectively are 0.418 and 0.612. This question is based on independent event case, which I just discussed with you. You see that probability that a crime is going to happen, a major crime is going to happen in the northern region is 0.412. So probability that this crime is not happening, probability that this major crime is not happening in the northern region would be 1 minus 0.412. Right, subtract it, you will get the answer, you will get the value as 10 minus 82, 9 minus 18, 9 minus 0.582, right? And probability that minor crime is happening in the northern region is 0.612. So probability that the minor crime is not happening in the northern region would be 1 minus 0.612, right? 10 minus 82, 9 minus 18, 9 minus 63, 0.388. It's clear? Okay. Similarly, it's given that the probability in the southern region, right, were respectively for major crime, probability of major crime in the southern region is given to me as 0.355. So probability of not happening of major crime in the southern region would be 1 minus 0.355. 10 minus 5, 5, 9 minus 5, 4, 9 minus 3, 6, 0.645. Probability of minor crime happening in the southern region is given to me as 0.520. Probability of minor crime not happening in the southern region would be 1 minus 0.520, which is equal to 0.48. Now what I'm supposed to find, assuming that all crimes occur independently of each other. So it's complete direct case of independent events. And likewise that crimes in 2 neighborhood are, the crimes in 2 neighborhood are also independent of each other. That means crime happening in northern region and southern region are completely independent. So can I say Pn intersection S would be Pn into Ps. and the probability of happening the probability of happening a crime in the northern region is probability of happening the major crime or probability of happening the minor crime. Similarly, probability of happening the crime in the southern would also be probability of happening of major multiplied by probability of happening a minor. But here we are supposed to find out what is the probability that no crime of either type is committed in of the neighborhoods, right? So either you multiply all of these four values or you multiply all of these four values. If you are multiplying all of these four values, then you need to subtract it from 1 to find out that no crime is happening. And this will straight away give you the answer. If you straight away, right, use this probability of not happening a major and minor crime in the northern region and not happening a major minor crime in the southern region. You can straight away multiply these values to get the answer, right? 0.582 multiplied by 0.388 multiplied by 0.645 multiplied by 0.48. Now this is completely based on the calculation. On solving this, you'll get it right 0.069, guys. This is the correct answer to the question, which is option number A, everybody. Very simple independent event case question, right? Very simple. Question number 3. The chances of India winning a cricket match against Australia is 1/6. Probability that Australia is going to win the match. Probability of India winning a match against Australia. Okay. Probability of India winning a match against Australia. So probability of winning the match against Australia is 1/6. So guys, probability of losing the match against Australia will be 5/6. So there, out of 6, there's one chance that India is winning. Out of 6, there are 5 chances that India is losing. What is the minimum number of matches India should play against Australia so that there's a fair chance of winning at least one match? So guys, here the important word is a fair chance. What do you understand by the word fair chance? See guys, fair chance means there are 50-50 chances that India is winning and losing, right? So what I basically want, so if I am saying that India has a fair chance of winning the game, that means it is 1 out of 2 chances is there that India is going to win the game. So what I want is to India play those many number of matches that India win at least one game. So guys, if I subtract the total probability of India winning and losing, I know is equal to 1. Now let's say that n are the number of matches that India is playing. Right, now out of 1, that is total probability, if I subtract the probability of India losing all these matches, right, in n number of matches, in n for n number of times, let's say n matches India is playing and there's a probability that 5/6 probability that India is losing the match. So in n matches, all of these, India losing all these matches is 5/6n, right? Now what I want is, I want India to have a fair chance of winning at least one game. So that means I want this match, this value to be greater than equal to 2. Because I'm subtracting the probability of India losing the match out of total probability. So I'll be left with India winning the match. And if this probability is greater than 1/2, that means there's a fair chance that India is winning the game, right? Now, all I need to see that for what value, minimum value of n, for what minimum value of n, 5/6 raised to power n is less than equal to 2. Now see that if I put n as 1, 5/6 you can see is greater than 1/2. So one match will not make sure that India is definitely going to win the one match. If I'm putting n as 2, it will be 25/36. This again you can see 50% of 36 is 18. This is more than 18. So this is also greater than 1/2. Will not work. If I put n as 3, it will be 125 upon 216. You see that 50% of 216 is 108. Now this is more than 108, so this is also not possible. This is also greater than 1/2. If I put n as 4, guys, you see the numerator I'll have 1296, 36k, and in the denominator I'll have 1296, in the numerator I'll have 625. Now 50% of 1296 is 638, and this you can see is less than 638. Sorry, 648. This is less than 648, so this is less than 1/2. That means the minimum 4 matches India need to play so that they win at least one game. Question number 4. Two team arrogant. Now see this guy. This is very special question. Very easy also. It's an actual XAT paper question. Two teams, arrogant and overconfident, are participating in a cricket tournament. The odds that team arrogant will be champion is 5-3. So guys, when I say that team arrogant will win the match, that means is 5-3. That means out of 8 chances, there are total 5 chances that arrogant will win. and 3 chances that arrogant will lose. So probability of arrogant team winning the game, winning the match is 5 by 8. Similarly, like this is for arrogant. For overconfident, right? There are four with the overconfident. The odds that overconfident will be champion is 1:4. That means out of five chances, right? Out of five chances, one chance that overconfident will win, right? Now, what are the odds that either team A, arrogant, or team overconfident will become the champion? So it's very simple case question, guys. It's a question of union of set, right? Right. So it will be P, either arrogant should win the game. Either it should be arrogant win the game, or it should be overconfident win the game, right? So basically what you do is you subtract, you simply find out P arrogant plus P overconfident minus P arrogant intersection or overconfident, right? 5 by 8, because winning arrogant and winning overconfident are completely independent of each other, right? So this is 5 by 8, 1 by 5 minus 5 by 8 into 1 upon 5. Solve this, you get your answer, right? 1 by 5, 5 by 8 plus minus 1 by 8, 4 by 8 plus 1 upon 5. 8 into 5, 40, 8, 5, 24. This will be 25. Sorry, this is 28. That is 4 into 7, 4 into 10. So out of 10 chances, out of 10, there's 7 chances that either one of them will win, and 3 will be that either one of them will lose, right? So 7:3 is the correct answer. D is the correct answer of the question, guys, right? You could have subtracted losing both the teams from 1 also. You could have used the concept of complementary case to answer the question quickly. Here's the next question from Zat. 6 playing cards are laying face down on a table. 2 of them are kings, two cards are drawn at random. Let A denote the probability that at least one of the cards drawn is king, and B denote the probability that of not drawing a king. The ratio of A is to B is what? So guys, we have 6 cards, right? 2 of them are king. Out of 6 cards, we have 2 kings. We have 2 kings, K1 and K2. Let's say that. And the 4 random cards, C1, C2, C3, C4. Let A denote the probability that at least one of the card drawn is a king. At least one of the card. So probability that at least one of the card is king. At least one of the card is king is, you subtract all that probability but none of the card is king. 1 minus 4 upon 6. 1 minus 2 by 3. That is 1 upon 3. And B, that the probability that none of the card is king. None of the card is king is straight away 4. That means all the cards that you're selecting, okay, sorry guys, let me do it again. We need to select 2 cards out of 4. We need to select 2 cards out of 4. See guys, we have total 6 cards, right? We have total 6 cards. Now out of these 6 cards, I'm having 2 king and 4 random cards, C1, C2, C3, C4, right? Now probability, A is a probability that denotes that at least one of the card drawn is king. At least one king card. At least one king. So I subtract all that possibility when all the 2 cards, right? 2 cards are drawn, right? 2 cards that I'm selecting is out of these 4. 4C2 upon 6C2, right? Which is 1 minus. 4C2 is what? 4 factorial upon 2 factorial, 2 factorial. 4 into 3 to 6, right? Divided by 6C2. 6C2 is 6 factorial, 2 factorial, 4 factorial, 6 into 5 into 4. I'm sure you know how to do this, right? This is 15. 6 by 15. That is 9 out of 15. The chances are that the card drawn is, at least one of the card drawn is king. Now B is the probability that none of the card drawn is king. No, none is king. None is king, right? That will be straight away 4C2 upon 6C2. That means all the 2 cards that I'm taking is from this one only, which will be 6 upon 15 that we have already calculated. Now what I want is to find out the ratio of A upon B. So A upon B. A is 9 upon 15 and B is 6 upon 15, right? That is 9 upon 15 multiplied by 15 upon 6. 15 or 15 get cancelled. Answer would be 3 upon 2. That's the correct answer question. Ratio of A upon B is 3 upon 2. Question number 6, guys. Probability that a randomly chosen positive divisor of 10 power 29 is integral multiple of 10 power 23 is a square upon b square. We are supposed to find out the value of p minus a. This is a probability question, but it is connected with the concept of number system. See guys, total number of, if I want to find out the total number of factors of 10 power 29, now you should know how to find out total number of factors. This can be factorized as 2 power 29 multiplied by 5 power 29, right? So guys, we know that any number which can be written as p1 power a multiplied by p2 power b. Number of factors would be a plus 1 multiplied by total number of factors. This is the number of factors. Total number of factors would be a plus 1 into b plus 1. So guys, in this case, number of factors will be 21 plus 1, that is 21 plus 1 multiplied by 29. 29 plus 1 plus 29 plus 1. Answer would be 30 into 3. That is, the total number of factors of this would be 900. Total number of factors. What I want is the factor to be the multiple of 10 power 23. So this is my total number of outcomes, right? I'm choosing any one of these 900 numbers. So this is my total outcome. If I want the number to be the multiple of 10 power 23, if I want that a positive divisor that I'm selecting has to be the multiple of 10 power 23, then I have to make sure that the power in which I'm selecting has to be greater than 23. That means if I want this number to be multiple of 10 power 23, it has to be 10 power 23 into 10 power 6, right? So see that the number of factors of this 10 power 6 is what? Right, 10 power, this is 23 into 10 power 6 is 2 power 6 into 5 power 6. So the divisors which are the multiple of 10 power 23 will be 7 into 7, that means 49. So see that a square upon b square, probability that a randomly chosen positive divisor of 10 power 29 is the integral multiple of 23 is favorable cases, that is 49. Total number of cases, that is 900. So see that here, a upon b will be 7 upon 30. So therefore, b minus a would be 30 minus 7, that is 23. D option would be the correct answer. Question number 7. Aditya has a total of 18 red marbles and blue marbles in 2 bags. That 2 bags are there, box 1, bag 1, bag 2. We do not know which bag have how many marbles. There are total 18 red and blue marbles, right? So there's some red marbles here and blue marbles here. There's some red marbles here and blue marbles here. But we do not know the numbers. The total number of marble is known to us is 18. Okay. Now a marble is randomly drawn from the first bag followed by another randomly drawn from the second bag. One ball is supposed to be drawn from this, then one marble is supposed to be drawn from this bag. The probability of both being red is 5 by 16. So guys, I'm selecting the probability of red ball from box 1. Probability of drawing the red ball from box 1 multiplied by probability of drawing a red ball from box 2 is given to me as 5 by 16. Nothing else is given, only the total number of ball is given to me. So we know that guys, there is one fraction. Probability of drawing a red ball from box 1 is a upon b. Let's say that this is a number of ball, this is b, right? Whatever is this, right? We don't need to assume it, that will make it complex. Let's say the probability of drawing a red ball from box 1 is a upon b, and the probability of drawing a red ball from box 2 is c upon d. And this value is given to me as 5 by 16. Now we know that a and c and b and d, all these values are integers, right? We know that all these values are integers. These values are integers, the only possibility, you see that you have a 5, that is 5 as a 5 is in the numerator, right? If there is any cancellation factor, right? If there is any cancellation factor, it has to be the multiple of 5, right? So the two fractions on being multiplied is giving me a value of 5 by 16. The possibility is that one of the fraction is 5 by 8 and another fraction is 1 upon 2. Only then you can make 5 by 16. There is no other possible case, right? There is no other possible case. I can make it as 5 by, where I can make two fractions being multiplied, when two fractions being multiplied is equal to 5 by 16. There is no other case. One of the case is, what if I have 2 in the numerator, multiply 2 in the denominator, this becomes 10 upon 32, right? but then you need to check it, right? Let's take a random case. Let's take this particular case here. If I'm selecting, right, two fractions which on multiplication give me as 5 by 16. Now this gave me the probability of drawing a red ball from box 1, that is 5 by 8, right? And total number of balls are 18. So can you see that here? Can you see that here? The total number of ball here are equal to 8, right? Because total number of cases are 8 here. And because red is a probability of value in the numerator is 5, so red ball must be 5. So automatically the blue balls comes out to be 3. So in box 1, if there are 8 balls, total number of balls are 18. So can I say the total here has to be 10 here? Now the red ball and a red ball probability is 1 upon 2. So can I say the number of red and blue will be 5 and 5, right? Now we are supposed to find the probability of both being blue. So see that probability of both being blue. That means I want the probability of blue ball from box 1 multiplied the probability of blue ball from box 2. Probability of blue ball from box 1 would be 3 out of 8 and blue ball from box 2 would be 5 out of 10. That is 1 upon 2. The answer will be 3 upon 16, right? C would be the correct answer. Now some of you might be thinking why I'm not taking the case of 10 upon 32. See that in that case, if I go for 10 upon 32 case, I need to again do some pairing, right? I can divide 32 as 8 into 4, and then this can be 5 into 2. This again finally reduced to 5 by 8 and 2 upon 4, right? So ultimately it will reduce down to total number of balls in box 1 to be 8 and the total number of marbles in box 2 to be equal to 10, right? So ultimately you will come down to this. Nothing else will satisfy this, right? So this is the only possibility of taking the number of balls to be 5 by 8. The two fractions giving you the multiplication of 5 by 16 as 5 by 8 and 1 by 2. A beautiful question and very simple one also. Now question number 8. Ramesh plans to order a birthday gift for his friend from an online retailer. However, the birthday coincides with the festive season during which there is a huge demand for buying online goods and hence deliveries are often delayed. He estimates that the probability of receiving the gift in time from the retailer A, B, C, D is 0.6, 0.8, 0.9, 0.5. The probability of receiving the gift from retailer A is 0.6. Probability of receiving the gift from retailer B is 0.8. From C it is 0.9. And from D it is 0.5. Playing safe, we order from all the 4 retailers simultaneously. You see that probability of receiving the gift from one particular retailer, that means A, is completely independent of getting a gift from getting a gift from retailer B, and that is also independent of getting the gift from retailer C. That is also independent of getting a gift from retailer D. These all events are completely independent. Now we are supposed to find the probability that his friend will receive the gift. So there's a complementary case and independent event case. All these events are independent. Probability that he is not receiving the gift from A is 0.4. Probability he is not receiving the gift from B is 0.2. Probability that he is not receiving the gift from C is 0.1. Probability that he is not receiving the gift from D is 0.5. Now probability that he is not receiving the gift, right? If I want probability of receiving the gift is 1 minus he is not receiving gift from any of the retailers. 0.4, 0.2, 0.1 into 0.5. 1 minus 5 into 4 into 2, 40. That is 40 upon 0.004. The probability that he is receiving the gift is 1 minus all the cases where he is not receiving the gift from any of the retailers. This will be 0.996. The probability that he will receive the gift is 0.996. This is complementary case plus independent event, right? All of these events, getting a gift from all 4 different retailers are completely independent. So straight away use this, right? You will get your answer quickly. This you see the geometric probability question. A coin of radius 3 cm is randomly dropped on a square floor full of square shaped tiles of side 10 cm each. What is the probability that the coin will land completely within a tile? So guys, we have a square tile, right? We have a square tile here, as you can see here, right? And this length is given to me as 10 cm. This length is given to me as 10 cm. What I want is Now a coin is dropped and I want to find out the probability that the coin will be completely within the tile. That means I do not want coins to be dropped on the edge. I don't want this case. What I want is to coin completely fall inside the inside the scale, right? The complete coin should be inside the scale. So see that the maximum case that I can take is that this is how a coin can be dropped. So see that the radius here is 3 centimeter. Now if in this particular case, if the center of the coin slightly shift on the left hand side, you see that a part of the coin will be outside of the tile. But I do not want the part of the coin to be outside of the tile. So this is the maximum position. This is the maximum value, right? Maximum length at which the center of the coins can fall, right? So if I want the complete coins to fall inside this square tile, this center has to need to have a distance of at least 3, a distance of at least 3 distance of at least 3 from the edge of the tile. So now this is 3. Similarly on the right hand side also the maximum, right? This center of the coin need to have a distance of 3 from this. Similarly the coin need to have a distance of 3 from this side also. Similarly the coin need to have a distance of 3 side from this also. So see that the square that I'm making inside should be, right, this length should be, right, should be equal to 100 minus 10 minus 3 from the left side, 3 from the right hand side. This length has to be minimum 4 and width also need to be 4. So you see that in case of geometrical probability, my answer will always be favorable area divided by total area. So when I'm throwing a coin, you see that my total area is the area of the outside tile, that is 100. Favorable area you can see is will be 4 square, that is 16. So probability that the coin will completely fall inside the scale would be 0.16. E would be the correct answer to the question. Question number 10. A dice is rolled twice. What's the probability that the number in the second roll will be higher than the in first? So guys, you know that when I roll a dice, the possible outcomes are 1, 2, 3, 4, 5, 6 in the first throw. In the second throw also the possibility are that the outcomes are 1, 2, 3, 4, 5, 6, right? So my total number of outcomes, right, would be, the combination would be 6 into 6, that is 36. What I want is the number on the second dice should be more than the number on the first one. So guys, you pick any random, any two numbers out of 6. We know that the possible outcomes are 1, 2, 3, 4, 6. Now if I pick any two numbers out of 6, let's say I'm picking 3 and 5. Now I can arrange them in the ascending order as only one possible way I can arrange them. 3 on first, 5 on second. If I want the number to be the second to be more than first, right? If I pick any two numbers like 4 and 6, then there's only one possible way of arranging in the ascending order: 4 first, 6 second. So the favorable outcomes, right? In this particular question, my favorable outcomes will be the number of ways of selecting any two numbers out of 6, because once I select any two numbers out of 6, right, it will be, I can arrange them in only in one way, right? If I want to arrange them in ascending order. And then the total number of cases. Total number of cases, as you know, is 36, right? 6 into, solve it, is 6 factorial upon 2 into 4, which is 6 into 5 into 4 upon 2 into 4. This is 15. So this is 15 by 36, guys. So favorable cases 15, total cases 36. Answer would be C option, guys. Question number 11. Ashok has a bag containing 40 cards. This is amazing question, guys, right? So we have one bag where 40 cards are there, right? And numbered with integers 1, 2 up to 40. 1, 2, 3, 4 up to 40. Now, no two cards are numbered with the same integers. Likewise, his sister Shilpa has another bag containing only 5 cards. 1, 2, 3, 4 and 5. With no integers getting repeated. Their mother Lata randomly draws one card each from Ashok and Shilpa's bag, right? And note down the respective numbers. If Lata divides the number obtained from Ashok bag by the number obtained by Shilpa's, what is the probability that the remainder will not be greater than 2? So basically you're picking one number from here and picking one number from here, right? What is the probability that the remainder will not be greater than 2? What we want is the number should not be greater than 2. Okay. So guys, we know that in this particular question, guys, if I have to go for total number of cases, you see that total number of cases, total number of cases, taking a one card from box 1, then taking another card from box 2. Total number of cases would be 40 into 5, that is 200. Now out of this total number of cases, what I'm looking for those cases where on dividing the number from the bag 1 by the number from the bag 2, the remainder should not be greater than 2. So see guys, if I am selecting, let's say that in this case, if I'm selecting 1, now, whatever number I'm selecting from box 1, my remainder will always be less than 2, because if I'm dividing the number by 1, remainder cannot be more than 1. In fact, remainder cannot be more than 0. Right? So, in that case, the first case, right? In the first case, when I'm drawing red, when I'm picking the number 1 from box 1, all 40 integral values from box 1 will be counted as my favorable cases. When I'm selecting the number 2 from the bag 2, in that case, again, if I divide any number from the box 1 by the number 2, my remainder cannot be more than 2. So again, all 40 numbers will be my favorable cases. If I am picking a number 3 from box 2, then again you know that if I divide any number by 3, my remainder would be either 0 or 1 or 2. In that case, again, all 40 will be my favorable cases. But then if I'm picking a number 4 here, then you see that if I want the number to be greater than 2 or not greater than 2, that means I need to remove all those numbers where I'm getting a remainder of 3, because when I'm dividing a number by 4, the possible remainders are 0, 1, 2 and 3. So these are the favorable cases, but this is not favorable case. Now from 1 to 40, there are only 10 numbers which give you, so all the numbers which are of the form of 4k plus 3 has to be eliminated. And from 1 to 40, right, I know that there are total 10 numbers which will give me a remainder of 3. So rest of the 30 will be the favorable cases. And if I'm picking the number 5, now if I'm dividing a number by 5, remainder of 10 will be 0, 1, 2, 3 or 4. I am supposed to pick those cases where the number is not greater than 2, right? So these are my favorable cases. So there will be, you can see that 10 numbers which will be giving me a remainder of 3, and there will be 10 numbers giving me a remainder of 4. So out of these, total 20 will not be counted in my favorable case, rest of 20 will be counted in my favorable cases, guys, right? Sorry. Out of 40, let's do the, okay, I'm picking the number 5 here. So see that, so all the numbers which are the multiple of 5k will be 5, 10, 15, 20, that is up to 40. Sorry, there will be 8 favorable cases, not 10, right? There will be 8 favorable cases, right? This will not be 20. And all the numbers which are the form of 5k plus 1 will be again 8, right? Again 5k plus 2 will again be 8, right? So there will be total 24 favorable cases, right? There will be 8 numbers giving me a remainder of 3, 8 numbers giving a remainder of 4. So 40 minus 16, there will be total 24 favorable cases. 24 numbers will be there which will be giving me a remainder that will be not greater than 2. So see that, guys, my favorable cases in this case will be 40, 40, 40, 120, 120 plus 54 would be 174. Right. So 174 is my favorable case, 200 is my total number of case, probability will be 0.87. C option would be the correct answer to the question, guys. Last question is there. Question number 12, a small store has 5 units of a new phone model in stock. Now, 2 white, 2 black and 1 red. So we have 2 white phone, 2 black phone and 1 red phone. 3 customers arrive at the shop to buy a unit each. Each one has a predetermined choice of the color and will not buy a unit of any other color. All the 3 customers are equally likely to have chosen any of the 3 colors. With the probability that store will be able to satisfy all the 3 customers. See guys, total case. Every customer have 3 choices of color. First can pick any 3 colors, second can also pick any of the 3 colors, third can also pick any of 3 colors. My total number of cases will be 27. Now those cases where all the customer cannot be served with their choice will be, because I have one red and two white and two black. What if all three customers selected the white? Will I be able to serve the customer? No. What if all the customer selected black color? I'll be able to serve all three customers? No. What if all three customers selected red? Will I be able to serve all three customers? No. What if person select two red and one white? Will I be able to serve the customer? No. Now two red and white can be arranged in three ways, right? So in all these three cases, I'll not be able to serve the customers to their choices. What if customers select two red and one black? Will I be able to serve the customer in this case also? No. So this can again be arranged in three possible ways, right? So there are total 9 cases where I'll not be able to satisfy the customer. So out of 27, 9 cases are there where I'm not able to serve the customer. That means out of total probability of 1, there are 1 by 3 probability when I'm not able to serve the customer. So 2 out of 3 cases, that means total probability where I'll be able to satisfy all the 3 customers will be 2 by 3. That is the correct answer. That is fourth option. That's it, guys. Thank you so much for joining the session. This is it. The complete topic of probability with required understanding to solve all the questions have been discussed in this video. You want to learn more concepts, you want more practice questions, watch all 3 special classes on probability. Thank you so much for watching the video, guys, and please subscribe to the channel of Easy Connect, and on this you'll find a lot of videos uh, for your CAT exam preparation and OMATs. In fact, I have covered 100% syllabus coverage for CAT and other MBA entrance exams right on the channel of Easy Connect with me. Subscribe to this. This will give you this use on the channel of Easy Connect. You can cover your 100% syllabus for CAT and OMATs. A lot of videos have been uploaded on this channel, guys. Thanks a lot, and please share it with all of your friends. Thank you.